As they work through the PEOE stages, explain why they would see that, then they actually pour the beans, mix them, and then explain it. This seems fairly simple, they all get it, but it's an important first step because the next step in this, okay, would be to not add 50 milliliters of beans, but to add 50 milliliters of white beans. Okay, so now go through the same PEOE, and to 200 milliliters of red kidney beans, we're going to add 50 milliliters of white beans. Now you need to be explicit again here. We've got two different liquids. The molecules in the liquids, or the particles in the liquids, are a different size and shape. But we still have 50 milliliters of the white beans, and we have 200 milliliters of the red beans. Now they go through the same PEOE to predict what they should see happening. And what we're trying to get at here is that the mass is conserved, but the volume is not. So they should predict that perhaps some of them will come up with the idea that these white beans will come in to fit between the spaces in the red beans. Okay? If that's not a big enough change for them and they don't see that, then you can always go to just regular old table salt. Okay, so the same idea is, now I'm using beakers here, and the purists out there are going to say you can't use a beaker to measure volume. You should be using a graduated cylinder, and you're right. We should be using graduated cylinders, and that may be, again, there's a skill that the kids need to learn. I did this with a grade 10 class, assuming that they knew how to use graduated cylinders and they could mass things properly as well, and we had to go back and reteach how to use mass scale and how to use graduated cylinders properly. So it's important that the students get a chance to do these things. So again, so now with my PEOE, I ask them to predict what will happen to when I combine 200 milliliters of red beans and I add 50 mils of salt to them. What will happen? Okay. Conversely, I could say, is there a difference if I add 250 milliliters of red beans to the salt? Does the order that I mix these things in make a difference? So there's lots of different ways we can do this. If I add the salt to the beans, so if I'm adding my representation of salt to, let's say these beans are representation of water, then you can see that as the salt dissolves in the water, it now fills in the spaces around the water molecules. So that's a really good analogy for one substance dissolving into another. So you don't get, when you put salt into water and stir it, there's not an increase in volume, but there is an increase in the mass, okay, proportionally. So what I would follow up with this would be, I would do this beans analogy and then give them a beaker with water and a beaker with salt and say, give me the molecule or the particle representation of what you predict will happen when we mix salt with water. Okay? I can also use this same analogy for alcohol and water. That's another one that students have a difficulty with, right? The red beans representing the alcohol molecules, which are larger and a different shape than the water molecules, and the salt representing the salt, which then goes in around the water molecules. Another good application for this is the whole idea of the separation. The idea of the separation between oil and water, or oil and vinegar, how oil tends to float on top of water. Remember, I was talking before about how does it matter which order we put things in. If I added, let's say this was, the red beans were the oil and the white was water, okay? As I shake the beans, look what happens to the oil. The oil floats on top. Students will talk about the oil floating on top when actually what's happening is the water is moving down through the oil. The water being more dense than the oil. And that the density of an object depends not on the mass of the particles themselves, but the space between them. Okay, again, this is a really good analogy to get that concept across the whole, going back and forth between the bean or the particle representation and then the liquid representations of the various demonstrations you can do for it.